Meeting has started. Dear doctors, marhaba. I hope that you're doing well. Ramadan Kareem. We have two special guests with us tonight. Arnold from EAGLET and Dr. Karen Brown from EAGLET as well. And this, your server, Felipe Arroyave from Spectrum International. Welcome to this meeting. I hope that you get all the knowledge that you want from this incredible instrument, and that together we can change many lives in the Middle East. Welcome to this meeting, Dr. Karen. I don't know if you want to go first or if it's Arnold's turn, but go ahead and start.
Thank you so much, Felipe. Our gratitude to all of you coming here for this webinar, but of course for Spectrum International and Felipe Arellave in particular for creating this opportunity. It is absolutely our pleasure here to present and give you a little bit of a insight into this wonderful instrument. So if you have any questions, don't hesitate to ask them in the Q&A, and we'll be following that. We're absolutely excited to take you on this tour. So let's get started. Let me just fight with the machine. There you go. There we go. Okay, so the history of a little bit of background of where we come from. So we are based in the Netherlands, in Holland, in Europe, and founded in 2012, where we were redeveloping an invention that was done at the University of Maastricht here in Holland. And after a couple of years of development, we launched that in 2015, and we kept on investing, and we keep on investing a lot into new features, new things that make this device more valuable for you. And so we had fitting algorithms that we connected in 2017. There was an ordering system, Direct Connect, we call that, in 2018. And Dr. Karen Brown will show that later in the second part of this presentation. We had in 2020 a big breakthrough where the software became a lot more easy to use, faster, and we had an enormous rise in the number of users since then. In 2024, what is important, we were with the first commercially available corneal scleral topographer in the market. And so it was so important for us to get grounding in science, in peer-reviewed publications. And in 2024, we hit 50 peer-reviewed publications. Of course, these are not our publications, but these are done by scientists all over the world, who use the data coming from this very precise device to then write papers about it. And for us so far, the big thing in 2025 was where we received the BCLA Industry Award, and that was just a fantastic moment to be. So where are we? You can see on the map, we are an international company. Our focus is the world. You see there's a lot of dots there, but we are working on getting a lot more dots there. And of course, we do that together with Spectrum International. So at the moment, we have about 415 customers right now, 40 plus countries. We are an open platform, so we carry almost all of the lenses that Spectrum International has, and then we have some others as well. And with our system, with our platform, up to date, more than 35,000 lenses have been fitted. So this is being used in many countries in the world, and we would love you to join the family of EAGLET Eye users. Let's talk technology. So the technology is called profilometry. And the thing that we do is you instill fluorescein onto the tear film, and then we project a vertical line pattern of cobalt blue light. And so when that cobalt blue light hits a fluorescein molecule, it will get scattered back in all directions. You see that on the photo on the right. You see there is a complete coverage of the front surface of the eye. And there's no hole, and it's equally dense in the periphery as it is in the center. So But what we do is we project from two sides, as you see on the diagram on the left, and each of these projectors has complete coverage of the eye. And this is very important because the two sides will balance each other out, which makes the device more robust for highly pathologic eyes, and it gives an unmatched data density that no other device currently available in the market can match. And we call that the gapless dual profilometry principle behind our technology. So what does that give you then? It gives you 500,000 data points, about 20 millimeters of diameter and coverage, 2 micron accuracy for the cornea, and 10 microns accuracy for the sclera. And we have a single shot technology. So it's very fast. We have case reports, we have posters out there for patients with nystagmus that this technology is capable of capturing without any problems. We capture the full front surface. There's no need for extrapolation. There is no gaps, nothing like that imaginable. And well, we'll show that later in what you can do more. So what are the advantages then? Is a much more efficient fitting process. We cut that chair time, those refits, we cut that by 300% plus. And you have a technology here, you have a device here that is just as good for corneal lenses as it is for scleral lenses. And this is basically your champion for all the specialty contact lenses. And there's another thing, because you have this very dense, highly accurate data, it allows you to let go of the old lenses that were hardly customizable at all to very customizable lenses. Free-form lenses, sometimes called, or cut to measure lenses. So that is the further step in the evolution. Is not just a faster measuring process, but being able to fit lenses that are really made for the shape of that particular eye. And we'll show some examples later on. And what is recently come to the market is the ability then on the front surface of the lens, on the optical zone, is to correct or to optimize, we should say, higher order aberrations on scleral lenses, which take all the customization, but also the visual acuity that you can reach for those highly irregular corneas to a next level. Well, our goal with this technology, with this device, with this platform, is to facilitate and to be a catalyst in innovation for specialty contact lens fitting. And we realized that we need to do more than just have a device with some software where you can analyze the shape. Most devices, they stop at step number 2. But what we have done in order to facilitate the fitting process based on digital data of the front surface of the eye is we started to create what we call first lens fit algorithms. So these are algorithms that will take the measured shape of the eye. We collaborate with those lens manufacturers, and they shared with us part of the back surface design of the lens. And so together, our algorithm can then already fit or indicate the final fitting parameters for the lens that will be your final lens. And the fourth step that we've done is the ordering system. So basically, with a push of the button, and Dr. Karen Brown will show that later on, push of a button, you can, for the lens and the manufacturer that you have selected, you can then place that order with those lens parameters that you have calculated in step 3 there. You can push that. But it's not just the order that you then send over to the lab of your choice. It's also, they also receive the measurement of the eye, of the two eyes, of that particular patient. And we have trained the consultants at the other side, on the lab side, on the lens manufacturing side, with our software. So when you then have a discussion, both sides will have access to the 3D data, and you will have an informed discussion with the consultants of the lab that you work with. And this is what we have in mind. We keep on investing into more things. So once on board, you're here from us. So this is the measurement process. You need to center and to focus the device. You have the fire button, so you're always in control. When you're ready, you push the fire button, and you saw how quickly those flashes are. It's just a few milliseconds. Let me just show that to you again. Let's see if we can do that. Yeah, here we go. So we hold open the eyelids because we want that vertical coverage. Then we center on the two Purkinje images, and there's two dots on the right where you do the focusing. You see it's a very intuitive process. It's a fast process, and that gives you that very accurate results. Okay, that's enough. And what you then get, these are just some of the measurements taken by the practitioners that we collaborate with. And you see that there's the pellucid, if you go the top line on the left, from left to right, so it's the pellucid marginal degeneration, eccentric cone. This technology is capable of measuring irregular shaped eyes more than any other device currently available. You see a central cone, you see a post-LASIK eye next to that, so it's flattened by the LASIK procedure. And in sunny countries, you will come across eyes with punctile quite often on a regular basis. And of course, when you're trying to fit a lens on that eye, it can be really tough to get that right. But with this technology, you measure it, you'll be able to share that with the lab of your choice, and they will be able to come up with a local solution that will be fitting. And also on the scleral side, you see on bottom left, you see that high toricity there. And Dr. Karen Brown will talk a bit more about that later on. You see all those different shapes, so highly irregular shapes. And before we launched this device, there was really no device that could measure the full scleral shape of the eye. And so we had limited knowledge of what those shapes are. And actually our perception was that it was, well, a little bit similar to the cornea, not much more irregular than that. But thanks to the research and those peer-reviewed papers that I mentioned before, we now know how irregular those scleras are, and they are particularly more irregular for pathologic eyes, right? With some condition of the cornea, advanced keratoconus, that sclera will be very irregular. And so irregular that the old-fashioned lens designs, they just won't give a comfortable and good fit. So you need to go to more customized fits. And that's what you see here. So spherical is less than 6%. Regular toric is less than 30%. And so the rest is more irregular. So we need to measure the sclera, but it also is true for the cornea. And this is highlighting for the corneal lenses is that most of the corneal lenses up till now are fitted on K values, which is just based on the central part of the cornea and eccentricity. The new way of fitting corneal lenses, and quite often these corneal lenses are 11 or some 11 plus millimeters in diameter. So you want to have a limbus to limbus coverage of the measurement of the eye every time you fit a corneal lens as well. And you always get, of course, the full cornea limbus to limbus measured with the eye surface profile. So we're an open platform. At the moment, there's more than 50 lenses connected. And you see the Boston side scleral lenses there carried by Spectrum. There are the lenses from Oculens. There's a lot of these lenses are in there. And as I mentioned before, there is the direct connect. So you can find Spectrum in the list of providers and select them and then place the order with them. Okay, I see a quick question. David Berkow. Shalom, David. So good that you're here on board. We're absolutely. David is one of our very early customers in the Middle East, and we're so happy. I'm just please explain. Sorry, what the sentence where you stated that ESP can measure HOA. That's a good question. No, to be precise, so we do not. The iSurface Pro Styler cannot measure HOA, but we collaborate with providers of aberrometers, and so they can. But why it is such an important thing to work with an ESP fitted, profilometry fitted lens, scleral lens, because HOA correction means that you have very precise local corrections of the aberrations, the higher order aberrations, but that requires that lens doesn't move, it doesn't rotate, and it doesn't shift. So you need a very precisely fitted lens. And again, we go then back to what is then often the best solution is you fit a customized lens based on the actual shape of the sclera on that eye, and that then assures that your lens will remain stable. It's well centered. That's also important, of course, and then a partner of ours or one of the providers of ours can then add the front surface HOA correction to the lens in collaboration with the lens manufacturer. I hope that that makes it more clear. Okay, let's move on. So yeah, freeform is the future. That is for sure, and we are so thrilled that we, with our platform, play a part in making that possible. As I said, 400 customers. We are very passionate about our customers. We stay in close touch, and our success is your success. So, sorry, your success is our success. And so we are very passionate about you, and so we are always open. We have a large staff of consultants that are always ready to support you in whatever way they can. Just a quick word on our website. If you want to find out more on the public website, eagleteye.com, there is an academy with lots of case reports, with videos, with posters. You can already do some research there on what this technology can bring. And that concludes my part of the presentation. How can you predict the final power? For that, we have an over-refraction calculator, and Dr. Karen Brown will show a bit about that later on in her portion of the presentation. This is where I thank you for your attention, and I'm happy to hand over to Dr. Karen.
I will come off mute. I think that's worked. You can hear me okay?
Yes,
Yeah.
we can, Doctor.
And I will see if I can move the slides along. That should also work.
But while you do that, to answer
Yeah.
Dr. Nasser's question, please remember that EAGLET has a direct connect software, Dr. Nasser, I'm sorry. And I'm pretty sure Dr. Karen is going to walk you through on how to do that. But yes, you can determine final power, and it's very easy. I can also show you on the contact lens side. Whenever you want to do a roundtable meeting with me, I can show you, or we can also get Eaglet to do a small session for you. But I'm pretty sure Dr. Karen will touch base on that.
Yeah. 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 We can sort of show you that in the live software in a moment as well. So hello everyone, and thank you for having me. I think this should work. Yes. Okay. So we're all up and running. That's always good. Like it when a plan comes together. So where we come in, so really we're more than just a new technology, you're purchasing equipment. It's also the training and the support that we give you as well. So we've got an Eaglet Eye Academy that will help you with the onboarding, but we're also doing one-to-one sessions, really to make sure that when you're up and running, you're taking good scans, because really all of this comes down to good scans. So everything that you do comes down to good scans. And as Dr. Jetlica often says, garbage in, garbage out. So really from the beginning, we will be with you, helping you with setting up the ESP, but also with the onboarding process and how to start taking good scans. And let's see if I can move this along now. Oh, yeah, there we go. So as we mentioned earlier, or so as I mentioned earlier, we have an Eaglet Eye Academy. So this is an online platform, and it really just has come about because we want to support you wherever you are. So wherever you are in the world, we want to support you. We have an online academy where you can actually dip in and out whenever you have time in between your clinic or when you get home. This really consists of how to set up the ESP and how to start taking measurements. So it's flexible, but it also means that we actually have online meetings with any of my colleagues. So, and I have the feeling Ricardo is also on the call, so you may come across him when he sets up training with you. So it's self-paced. You sort of pick out the modules that you want. You can do it in shape of a video. You can do it in shape of a PowerPoint. So really, whatever way you learn is the way you can pick up anything that you need to know about the ESP and how to take measurements. We really encourage the one-to-one Zoom sessions because you get a lot out of it. It means often that we can actually be in your consulting room whilst you're taking scans, so we can talk you through how to take scans, what a good scan looks like, but also give you some points. Once you're up and running, we have a support button in our software that then means, oops, sorry, that did not mean to do that. Where we can support you. You can share scans with us. We can give you feedback on, okay, watch out for this, get that lid out of the way a little bit more, use different drops. So it is really a one-on-one training session where we can just be there whenever you need us. Multilingual. I mean, I'd like to say that I speak many, many languages, but my limit is probably Dutch and English. I can probably understand some German, but we have got Ricardo who speaks Spanish. And then, of course, we have Arnoud who speaks French and German. So we are going across any languages, so any time zones. So the other thing, of course, is that based in the UK. I'm based in Italy. Arnoud is in the Netherlands. We have another support staff in the Netherlands, and Ricardo is in Guatemala. So we really do cover all of the time zones. Quite a unique part that we have that I will show you in the live software in a moment as well is our support button. You can upload measurements for us to give you feedback. We will look at your scans. We will give you feedback. Any issues that you have, any questions that you have, you can again use the support button where one of us will pick it up. So we're very quick with replying to any of the support requests that you have. On the EAGLET Eye Academy, so once you've actually been enrolled on the academy, we also have an FAQ knowledge base part where you can find questions that you may have, but most of the time we will be here to answer those questions for you as well. Okay. So we're now just going to be looking at some of our case reports. So really, it's just sort of to show you how multifunctional the ESP is. We've got two cases here. So we've got something with a dystrophy. And then after that, we go into an ortho-K case report. So here you're looking at a patient profile. We've got a 54-year-old male. You'll be seeing some of the images in a second when I move this on. So this is a patient that generally struggled with anything like a scleral contact lens until you realize that actually there's so much more going on. So here you can actually see this is one of our maps. So once you take the image, you pull the image into our software, and this will show you the source map. On the source map, you'll see some indicators. So it will give you an indication on how well is it centered, have you got enough coverage, and focus. So here you can see we've got some really good focus, probably could have a little bit more coverage, but that really depends on what lens you're going to fit. If we're really critical, we'd probably say, oh, get that eyelash out of the way a little bit more to get less artifacts. So this is the bisphere elevation map. So the bisphere elevation map, it really means that you've got two spheres. So you've got your corneal sphere, you've got your scleral sphere. These are the best vision spheres. So you've got above and below the reference sphere. So on the right-hand side in the software, again, I will show you that in a moment. You can also find the eye metrics. So you've got your SIM case, but you've also got your HVID, your VVID, and you've got your pupil diameter. As I say, I will touch back onto that when we get into the software. Another one of our maps is actually a little bit of a roadmap. So we normally say, okay, use it just to give you an idea, what does this eye look like? So what we're showing here is actually irregular. So you already know that it's probably not going to be just a standard spherical lens. So it will just give you an idea. It will give you an idea on what lens to design or what lens to actually decide to go for. With that, in our software, we also have the chord calculator. So you can just plug in certain chords. So say you've got a lens that's going to land at something like 13 millimeters. You can plug in 13 millimeters. You can actually see what's going on at that particular chord length. So here you're seeing like, okay, so if the min sec max sec difference is between 50 and 100, more than likely you're going to need something like a toric in a haptic. So it will just talk you through it. So this whole nomogram will just give you a step-by-step guide. Having said that, most of the time in our software, it will do this for you. So really, it gives you an idea on what lens to go for, but in actual fact, all of the algorithms are set up for this and they will do it for you. So here I was talking about the 13 chord length. You can actually see the difference there. So you've got 160 microns. So it's already telling you you need to go for something like a toric transition zone. And if I go on to the next slide, it will show you a little bit more. Ooh. So here you can actually see where that's measured. So which part of the lens that's measured. And I will move on to the next slide. Sorry. There we go. So here we're plugging in 15. Again, it will give you, so we've got the chord length of 15. It's now saying that if you're looking at the T-sec and the N-sec and it's over a certain amount, you are going to need something like a toric zone again. So here at 15, we're looking at 280 microns, I think. Is that correct? Yes. So it just talks you through the whole nomogram. But as I said, the algorithms will do it for you, depending on which lens you go for. So again, talking about this bit, it will show you the chord length of 15 and how different it's going to look. And then from there, it will just point you in the right direction of which lens to order. I think I did this bit. So really, it will sort of point you towards a free-form lens. So really, the bigger the differences and the more pathology you've got going on here, the free-form lens is going to be correcting, or it's going to be fitting much better with all the details that you have. So once you've decided which lens to go for, and again, I will touch back on that when we go into the software because it will give you a much better idea. In this case, the measurements that were taken were shared with the lab, and a beautiful lens was made. So with the Direct Connect, which I'll show you in a little video as well, all the data does go to the lab, and the lab will process that into a lens. So a lens was used for over-refraction, so you get an idea on what sort of prescription to go for. So you can take out one of those steps and it will come through with a prescription. I think that was a question earlier in the Q&A. So again, we will show you that in the software in a second as well. So that's, I'll go back here. There's just a little idea on how it works. So you go to the result tab. From there, you go to first lens fit. And you choose the lens that you want to go for. The apical or mid-peripheral clearance are set, but you can override it if you need to. We normally recommend leave it until you've had some lenses through so you can actually just see how the lens settles. Then you click calculate. It will just come up with a suggested base curve. I think it stopped there. Oh no, there we go. And we'll just move on to the next slide. So this is how it goes to the lab. So you would go with the Direct Connect. Let me just go back there. Again, I will show that in the software in a second. You go to the Direct Connect and all the data gets sent to the lab. So the final lens, I will show you an image here so you can actually see beautiful fit. The lens was comfortable. The patient was absolutely happy with it. His vision was corrected. Let me just see if that actually comes up in a second. You can see here there's no blanching, there's no redness. The lens just fits beautifully well. Got an OCT image here so you can also see how good the clearance is and how even it is. Very interesting eye. Again, sort of the left eye, beautiful fit. There's no blanching, there's no impingement anywhere. And as we mentioned, the patient was super happy with this lens. Visual acuity actually came up to 2025 and 2020. So after the review, the patient was really happy with the lens, and patient feedback, he reported improvement in both comfort and visual quality. And this was the smart lens. So this is the freeform smart lens available from Spectrum. I shall just move on to the next one. So breaking the rules. This is actually a lens fitted by Ricardo, who is also on our professional affairs team. We call it breaking the rules because, of course, for Ortho-K, you've got set rules and regulations like don't fit over this amount, don't do so high sales. But in actual fact, if we're sort of thinking of something like the Limbal Ortho-K lens from EAGLET, again, available from Spectrum, it just gives you more opportunity to actually fit those patients that will just fall outside any of the other ranges. Sorry, I'm messing around my share. There we go. Okay. So for Ortho-K, again, with the ESP, it works just as well. You still take measurements. You make sure that your focus is good. You make sure that you have enough coverage. For the Ortho-K lens, you're not going to need quite as much coverage as you would normally need with a scleral lens. So make sure that you've got a good vision of the limbus before you proceed. Make sure that you have a good scan, then pick your lens design and follow up. So here, breaking the rules, we have someone of he's a 15-year-old. His vision was not actually that great, of course, 20 over 160 in both eyes. Quite high sales, but also a very large HVID. So of course, a lot of the time with the standard ortho K lenses, you're going to struggle. So you're not going to get enough of the correction on the optical zone. So this is why Trent Limble ortho K was chosen. So when we're talking about measurements, so this is just an image to show that, of course, you can make sure that you have good focus, that you've got good centration, and that you've got enough coverage for the ortho K lens, but also looking at the quality of the scan. So we would normally recommend that you also check the tangent angle map. So there's a little example here that you can just see that it's streaking a little bit. So it's breaking up, which means that the fluorescein pattern is breaking up, and you can see that red line through the image. If you compare it to the image that's right next to it, you've got a nice even grid pattern, but you've also got a really nice looking tangent angle map. And if you look at the corneal map, that looks smooth and sorry, that looks smooth and even. So for that, you can then proceed with an ortho K lens. So as we said earlier, data is important. So make sure that you get good maps to make sure that that data can actually cope with it. So this is what we were talking about, evaluate the scan. So we would normally say take 3 scans, and that's really so you can pick the best. So you put the fluorescein in, you take 1 scan, get the patient to blink, take your second scan, blink, take your third scan. This is purely to pick the best scan. So this is not to extrapolate or merge images. This is really just so you have the best chance of getting the best scan. So from there, you will choose your lens. So there's a little video here that's now going to pick the new vision lens, which is the Trent Limble Ortho K. You fill in your spectacle prescription. And from there, you've set the measurement as baseline, and then you can just go straight to the lab. It will open up a little order form where you can then pick your material and send it straight to the lab. They will get our scan so they can see what you can see. And then get the patient to wear the lens for a while. They will then come back for the follow-up, and you can compare the maps with your comparison maps. So this patient came back after 3 months. He would have been back a little bit earlier, but this is the aftercare after 3 months. So you can see here that the eye was looking really healthy. He's comfortable sleeping in the lenses. Stable vision for 12 hours a day. So he really didn't need to put the lenses back in early. He can just cope the whole day with this particular prescription. He was 20/20 in both eyes. What you can see here is the comparison maps. So the first map is your baseline map. Then you've got your actual curvature difference map, and you've got your tangential curvature difference map, and the power profile. So really this is to show you how much the power has changed, but also how much or where the lens is fitting and what sort of zone, what sort of correction you've had on different zones. So this is the left eye. Again, it's looking great. So you can see that the lens is fitting centrally. The power change, again, sort of you've got a good power change here. So you can see the steep and the flat axis, and it's been corrected very nicely. Fluoro images. So again, it's looking like a really nice fitting lens. You've got a few insertion bubbles there, but they will actually clear up whilst sleeping. And really, it's there to fit smarter. So don't stick with. I mean, you will find that once you have an ESP, you are going to be wanting to fit more difficult ones just because it copes so well with different pathologies, and really you get some really great results. I am just going to share my screen now, which I'm guessing it probably means that I stop sharing and then share my software. Would I be right in that? Um, so can I actually share my screen? Yes, I can now. Thank you very much. So as we said, this is the live software. So can you see my screen okay? Yeah, perfect. So I've sort of just made a bit of a collection of different scans here. So I think if we just open up one of the scans, you can just have an idea. Setting up a patient is super easy. Let's go back to that first. You would go in the little plus. You would need to give a name, the family name, and patient ID before it opens up the camera. And I will just open up this scan. So normally, if you have taken more scans, they will all be listed on the right-hand side of the screen. And this is how we open. So we said earlier, you've got your corneal sphere, you've got your scleral sphere there, and then you've got your heights above and below. So the reds are above, the blues are below the reference sphere. A whole list of maps that we were talking about. So we would normally check the source map. So it will give you a really good indication of how good your scan is. This is also something that you can see in the pre-process. So once you've taken a scan, it will actually give you that before you save them into the software. So in this case, you can see the focus is slightly out. So these two vertical dots that you can see here need to be vertically aligned. So you want to make sure that they're vertical, and really you want to make sure that they're green. Centration, that really looks at the horizontal Purkinje images. You want to make sure you have the red cross in the center of the pupil. And then of course, coverage. Coverage, it all depends on what lens you're going to fit. So something like this, 7.6, it's green. You can pretty much fit any lens you like on that. The grid map is, we mentioned that earlier as well. So this is the grid where you have your vertical reflections. So you want a nice, smooth vertical line pattern. But from a quality point of view, we would look at the tangent angle map. So of course, this is quite a nice example. But if you were to see something like horizontal lines, it normally means the fluorescein is breaking up, or you need a little bit more dry eye drops. So from taking the scan point of view, stepwise, you would start with a dry eye drop, do your alignment, wet your fluo strip with the dry eye drop, and just make sure that you get a nice fluo blob hanging at the end of your fluorescein strip to get that all over. So you don't want so much quantity, you want the quality. So just let your dry eye drop soak up the fluorescein. So we touched a little bit on the chord length calculator here. So we can just type in 13 here. And here you can see that difference that we were talking about in our nomogram earlier. So this one is a difference of 90 microns. So in an ideal world, you probably would need to go for something with a toric in a haptic. You can enable your bi-curve just to sort of show what that's going to look like with your bisphere. You can see that here. Then on the right-hand side, you have your I-metrics that we were talking about. So you've got your sim case, you've got your eccentricity, you've got your limbus, your HVID, VVID, and then of course your pupil and your pupil offset. Same buttons at the bottom there, but if you actually click on those, it will show you the eye in this case with the tangent angle map. HVID, VVID is always worth checking because of course a lot of the diameters are based on the HVID. It will normally plot it in the right place, but if it's a lot of distortion going on, you can pick up the calipers and just place it where you want it to be. It will be adjusted and it will just be saved like that. And it shows you your iris, your pupil, the photopic pupil, conic, and you've got your grid there as well. We just go back to the bisphere elevation map. So we were talking about the first lens fit. So if we go to first lens fit scleral, and we're going to pick, let's find spectrum on my little lists. I think I can go there through EAGLET. And we go for the Smart Lens Pro. You can pick your diameters. And this is what we've shown here earlier. So you've got your apical and your mid-peripheral clearance. From there, you click Calculate. This is normally quite fast, but of course we are all on Zoom on the same Wi-Fi here. So it's now giving you the sag, it's giving you the base curve. So from there, I'm just going to click on Smart Lens Pro. This will open up another order form. Which I'll just move over to the screen here. You just fill in your account number. Normally, only you have to do that once because it will pre-populate after that. So all the details there. We have new order or remake. Are you ordering 1 or 2 lenses? The patient name is already copied over. Just indicate if you're ordering 1 or 2 lenses or as a pair. Then, of course, you've got your diameter that's copied over, lens rotation, everything here is copied over. Now, someone asked earlier, what do you do with the over-refraction? So in this case, you would actually say, this is the lens that we've used, this is the power that the lens has, and this is the over-refraction we found. The rest will all be calculated for you. You then choose your material, and from there, you can just click Submit, and it goes straight to the lab. So it will get your order form, but they will also get your scan as well. So go back to the software. I'm just going to go back to my patient list and find an Ortho-K patient here. So this is my Ortho-K patient, and you could already see on the menu here that it's marked as baseline. So the 1 means it's your baseline measurement. So normally when it's the first time, it will give you the option of you need to click it to set as baseline. So here we've got the baseline measurement. So we are ordering the lens based on this. Again, we go Ortho-K, we go AccuLens New Vision. Your diameter is set there. You just put in your spectacle prescription. And then after that, there is actually nothing else to do. So you again click the New Vision tab, and this will all be transferred to the lab. Again, an order form will open up. It means that you can choose your material again. Are you ordering 1 or 2 eyes? Again, sort of your refractive error, although normally that would copy it over if I put it in. And again, you will click Submit, and it will all go to the lab. Go back to the software. So from here, of course, you now have this beautiful lens that the patient has been wearing for a little while, and you go to your follow-up map. So you take another scan once the lenses have been removed. This is my follow-up map. You would go back to First Lens Fit Ortho-K, and this is where you then can see your comparison maps. So again, it will, let me just see if I can get this out of the way. I can't. So it will show you your baseline. So your initial measurement, it will show you your actual curvature difference map, the tangential curvature difference map, and your power profile. So really all the details that you need to see if the lens is fitting, is the lens central, has it done a good job in changing the myopic prescription. The other options, of course, we have our GP lenses, which works pretty much the same. Again, you get a good scan, you click the button, and the process is the same. What is worth just showing you here is our support button that we were talking about. So the support button really is just anything. So sharing your scans, talking to us, the support button is probably the easiest way to get hold of one of us as we are covering different time zones. One of us will see the support request when it comes in. So to share measurements, it's super easy. It's probably nicer to actually show you one that has numerous measurements. So you can do it in two ways. So you can go to your hamburger menu, which also enables you to flick through the measurements. Say you wanted to share all of those. You then go to the support button and it's just automatically attached them. You can then create a little button, sorry. It will create a little email that it will open up. It will send us the scans so we can see what you're seeing and give you feedback that way. Again, it's a little bit slower than it would normally be, but it's just a little email that then comes to us.
Dr. Karen, sorry to interrupt. Do you think that you can also show them the 3D image and the sclera and cornea image? Dr. Ricardo did it in a webinar we hosted recently,
Yeah,
and
of
that was
course. Yeah.
incredible.
Yeah. So this is sort of the form that it opens up to share the measurements. So yes, I will go back to the software here. So we go to, so the 3D image that you're talking about here is this one. So you can actually just show the patient, like, look, this is what we're looking at. You can turn it around. You can just sort of say, this is why you would need this lens. Really, this is why we're recommending what we're recommending. The tangent angle 3D does the same, but for us, that normally means we can actually see if there's artifacts. So if there's like dryness, this shows up really well on the 3D map. The scleral profile. So this is what we were talking about earlier, where you could see the irregular cornea, so the irregular lens when it was recommended the freeform. So this really, the colors in this case mean we have toricity. We've got a quad specific. So here you've got fairly spherical, but actually going towards the outside, you can already see that's changing. So really, corneal data does not correspond to the scleral data. This is why this is so good, where you have the whole of the image, you've got the whole of the sclera as well. Corneal elevation map. There's probably a better one if I choose the original measurements. So this is the regular pattern that we're looking for. Of course, if someone has been wearing Ortho K, you get probably a little bit more distortion. So if they've been wearing Ortho K lenses, just make sure that they wash out before you actually start fitting them. And that's with any scleral lens, really. The better the data, the better the result you're going to get with the with the lenses. So, Felipe, was there another one that you wanted to touch on?
No, that's exactly what I wanted to
Yeah.
see. Thank you.
Okay. I was just thinking of showing you something else and it kind of slipped my mind. Arnold, is there anything else that you think I should show here? No. Okay. Does anybody have any specific questions? Is there anything you would like me to show in the software whilst we're online?
So, doctors, imagine scanning the patient and sending us the data, and we manufacture a lens that fits like a glove to your patients. This is the future of specialty contact lens fitting. So ask any questions. We have time. We have Arnold here. We have Dr. Duarte. You have Helena, and you have Dr. Karen as well. And of course, you have me on the contact lens side. So what questions do you have? Dr. David, you're an incredible fitter, and you have used this technology for quite some time. We get a lot of your orders through EAGLET. I'm pretty sure that you're happy with the system. You can tell us your experience through the chat. Can we see a hybrid lens? Dr. Ahmad El Bata from Egypt is asking us to see a hybrid lens.
Yeah, so where the hybrid lenses are still available, it would be the Synergize, where you can then choose your Duet, your Ultra Health, or your Ultra Health FC. it will do the calculations for you, but there is no direct connect. So I will just click on there and it will still do the calculations like it's done with all the other lenses. But it is then something that you need to share with the lab, which is easy enough to do. You can sort of go to the print button and it will give you a little print report with all the details that you need for the lenses.
So, Dr. Ahmad El-Bata, imagine, so the lenses that do not have direct connect, but you can calculate them, just like Dr. Karen was showing. You can send us that data and we can analyze that data and we can help you pick the best lens. So instead of going through the fitting set and multiple exchanges, we want to reduce your chair time. We want to reduce your imports, exports. So even the lenses that do not have direct connect, EAGLET is going to help you determine which lens to use, either from the fitting set or the final lens that you need to order from the lab. And we can help you analyze this data. And not only with hybrid lenses, we have it for Mark Envy, we have it for CRT, we have it for ortho-K lenses. So this is just an incredible instrument. Dr. Nasser Al-Shalmi from Oman asks us, what is the most challenging in using the EAGLET?
Well, I mentioned before that this device allows you to measure highly irregular eyes, but these are pathologic eyes. Quite often the tear film will be severely disturbed, and so you need to think on your feet to make good scans of these patients, but you can, and we've got a wonderful supportive community of ESP users across the world. We have a Facebook group, a closed Facebook group just for ESP users, and there are several WhatsApp groups as well where people exchange information. And of course, there are our consultants who, Dr. Karen Brown is a good example, and Dr. Ricardo Duarte as well. So they're there to help you overcome and get really excellent at making good measurements also of the most difficult eyes.
And we pride ourselves in education, Dr. Nasser. As you know me, I do webinars almost every single week. We do have a Spectrum University YouTube channel where you can go in and learn. And we have a robust team of consultants. So we have 3 doctors in staff. They're all ODs, and we can always help you navigate either EAGLET or the contact lens side. Dr. David Berko, which is one of our customers, says, yes, Philippe, this is marvelous synchronization between Aculens and EAGLET makes the fitting very smooth. Less chair time, less lens changing, and very satisfied patients. Could not fit without EAGLET today. Thank you so much, Dr. Berko. And Dr. David is also fitting now ortho-K lenses through EAGLET. So that makes me very proud and very happy to see your lenses coming through, Dr. David. Dr. Nasser, I'm sorry, how can I still benefit from EAGLET if I'm fitting the lens without connecting to the lab that has connection with the software? And I'm pretty sure you're referring to Atlantis, right, Dr. Nasser? You can benefit from it because think about it. And I spoke with Excel Contacts this morning. I had a conference call with them at 9 a.m. my time. And I told them about EAGLET, and they love to see EAGLET scans. Why? Because they know exactly where that pinguecula is. They know exactly how much toricity they need to apply to that lens. So even though Atlantis does not have a freeform lens, you can still use this technology to fit Atlantis lenses. This technology is not only to fit scleral lenses. Remember, you can use this technology to fit corneal lenses. You can use this technology to fit ortho-K. You can use this technology just to show your patient how irregular their cornea, the limbal, and the sclera is. So to come back to your question, Dr. Nasser, yes, you can use this data. We can use it to fit Atlantis lenses, and they will exactly know how to prevent a lot of chair time. I've seen a lot of your orders, and sometimes your patients have 2 or 3 exchanges Two or three exchanges mean that we have to ship 2 or 3 times to Oman. You have to pay 2 or 3 times taxes, and 2 or 3 visits for you. So we want to reduce the chair time, the amount of lenses that we send you, and the amount of imports and operating costs that you are incurring because not having this technology available in your practice. I hope I was able to answer that question. Do you have any more questions, doctors? Anything that you want to add to this? Arnold, Dr. Karen, do you want to add anything to finalize this meeting?
No, I just want to thank everyone for being here. It's been an absolute pleasure. I hope this has given some insight and given some energy of what the potential is that you could do with profilometry, with the eye surface profiler, and with the lenses that are connected. So our team stands ready to welcome you, hopefully very soon. We're very happy to see Dr. David Berkow and also Dr. Kyriakos Telamitsi, both customers, users of the ESP for many years, and we cherish our community of users, and well, we're very grateful.
Thank you, Arnold. And just to emphasize, Dr. David Berko is stating in the chat, I must emphasize again, less lens exchanges with EAGLET. That is something that we all want to achieve. I want to produce less lenses. I want to export less lenses, and I'm pretty sure you want to have that patient leave your office with 20 happy and not seeing him 3 or 4 times almost every single month. So thanks to everyone. Yes, there's going to be a link for this session. Every single person that registered for this session is going to receive the link so they can watch the webinar again at their own time. And again, we're always here to help you with EAGLET or with the contact lens side. I also want to welcome the people that recently purchased an EAGLET. We have 2 doctors from Iraq right now. We also have a doctor from Egypt that recently purchased the EAGLET. Now Arnold and I are working on exporting those devices to you as soon as possible. So thank you for trusting EAGLET. Thank you for trusting Spectrum International. And again, let's change lives one lens at a time. Thank you so much. Thank you,
Thank
Arnold.
you.
Thank you, Dr. Karen. Thank you. And please be safe.
Thank you.
Bye-bye.